Go is a language designed to improve systems programming. Go includes abstractions that simplify aspects of low-level engineering that are historically difficult: concurrency, resource allocation, and dependency management. In that light, it makes sense that the Kubernetes container orchestration system was written in Go. Erik St. is a cloud developer advocate at Microsoft, where he focuses on Go and Kubernetes. He also hosts the podcast Go Time and has written a book on Go called Go in Action. Recently, Erik helped build the Virtual Kubelet project, which allows Kubernetes nodes to be backed by services outside that cluster. If you want your Kubernetes cluster to leverage abstractions such as serverless functions and standalone container instances, you can use Virtual Kubelet to treat these other abstractions as nodes. Erik also discussed his experience using Kubernetes at Comcast, which was a great case study. Near the end of that episode, he also talked about organizing GopherCon, a popular conference for Go programmers. If you are organizing a conference or thinking about organizing one, it will be a useful piece of information for you. There's lots of discussions about the hazards of organizing a conference. Full disclosure, Microsoft, where Erik works, is a sponsor of Software Engineering Daily. Today's episode of Software Engineering Daily is sponsored by Datadog. With infrastructure monitoring, distributed tracing, and now logging, Datadog provides end-to-end visibility into the health and performance of modern applications. Datadog's distributed tracing and APM generates detailed flame graphs from real requests, enabling you to visualize how requests propagate through your distributed infrastructure. See which services or calls are generating errors or contributing to overall latency, so you can troubleshoot faster or identify opportunities for performance optimization. Start monitoring your applications with a free trial, and Datadog will send you a free t-shirt. Go to softwareengineeringdaily.com/Datadog and learn more, as well as get that free t-shirt. That's softwareengineeringdaily.com/Datadog. Erik St. is a cloud developer advocate with Microsoft. Erik, welcome to Software Engineering Daily.
Thanks. Glad to be here.
Yeah, it's great to have you. So we're going to talk about Go and some various systems that are built with Go. When Go was started, when the language got started, the primary languages around that time for low-level systems programming, I think, were just C and C++. There were a few other fringe languages, but mostly it was C and C++. What were the shortcomings of the C and C++ language environments?
I think there's a lot of complexities in the languages themselves, especially as they've been expanded over the years, especially when you talk about like C++ and some of the versions there. And there's a lot of foot guns there, And I think that what they were looking for was, one, a language that was more simple and easier to reason about, without having 20 ways of doing the same thing and, confusion looking at code. And in addition to that, some of the newer languages, one of the things people love about them is a garbage collector where you're not having to manage your own memory and worry about those things. But I think the primary motivation was also to design a language from the ground up that thought about concurrency from the beginning. Because when we think about like threads and some of the patterns that we use for concurrency and parallelism, these were afterthoughts, right? All these languages that are being used as systems languages now, they were added on after the fact as far as, instead of thought about from the beginning.
What did that lead to? What were those low-level, because historically low-level programming is really difficult around these issues of concurrency or resource sharing. I think about semaphores and mutexes from college when I had to program in my operating systems class. What are the language mechanics that Go introduces to make those concurrency problems easier?
So when we think about Go, kind of the two primary ones are Go routines, which we can kind of think about as lightweight threads. Most people use them just treating them as threads, but under the covers, these things are actually multiplexed across real operating system threads. The difference between like a Python or Ruby is that there's no global interpreter lock and things of that nature. And then in addition to that, the concept of channels, which I want to say was Squeak or New Squeak that they borrowed that from. But this is based off the CSP paper, the Communicating Sequential Processes white paper. And essentially, it's just a way of passing data across Go routines in a synchronous way. And they can kind of be used as queues if you use buffered channels. But this kind of allows you to hand off control of the data to a different Go routine.
Did they borrow from the actor model of concurrency for that?
I think the channel aspect was primarily based off of the CSP paper, and I think it was Newsqueak. There's a couple talks by Rob Pike where he talks about kind of the history of the language, and he goes through, and I think Oberon and some other languages, some of the different concepts were borrowed from.
Okay,
but I think one of the things that people love about Go is there's like 25 keywords. It's really easy to reason about. You can kind of fit the entire language spec in your head at one time.
And was that another one of what were the objectives of the creators of Go? You mentioned Rob Pike. This is a guy that's been around forever designing languages and systems. What were the objectives of the creators of Go?
So they wanted to create a new systems programming language, and they were primarily targeting, C programmers and C++ programmers. With concurrency being at the forefront of it, a very simple language that people could reason about, because they were looking at designing a new language for large projects where tons and tons of people were working on it, and people could easily just jump in and out of it without, because when we look at most languages that have been around for a long time and kind of have, I don't want to call it cruft, but they accumulate features over the years. And, then everybody kind of has their own way of doing things. And I think that was some of the primary considerations when designing it.
So when did you start working in Go? What pushed you into starting to build programs with Go?
So I started in late 2011. Well, I looked at it in 2009 when it was first released. I worked for Disney at the time, and a few of us huddled around and looked at it. And it was kind of like, oh, this is really cool. And it didn't really sell me. That's the one thing that I find hard about Go, where it's like, okay, what's your elevator pitch? Why should you use this? And it's like, there's not a silver bullet, everything that's there and everything that's not there. And it really took me using it to fall in love with it. So late 2011, I started at a company, and there was a small service that was running. It was getting a lot of traffic, and it happened to be written in Go. And none of the rest of the team kind of really wanted to learn Go. And I've always been I love learning new technologies. So I'm like, why not? I looked at this a couple of years ago and it looked kind of interesting. I'll learn it. And then that was really like, as I started building stuff, especially highly concurrent stuff with it, that I really started falling in love with it.
And what are the kinds of applications that are a good fit for Go? Like, what were you working on at Disney? And I guess you could talk about later at Comcast as well. What are the kinds of things that you've seen be a good fit for Go?
So at Disney, they may be, actually, I think I've heard of some groups using Go now, but at the time they were primarily a Java shop. So this was just kind of, programmers geeking out, looking at a new language. But yeah, like as I said, the language was really designed for systems programmers. And what they didn't expect was so many of the Ruby and Python crowds to kind of come to it. Because a lot of people are starting to build these large scale applications using like Django and Rails, and they're starting to run up against performance issues, and they're looking for something else, and they don't want to go to like C or C++. And that felt like really great middle ground for people. So probably in the same vein as me, they started experimenting with it. And as you write code with it, like you really start to fall in love with it. Right now, a lot of people are writing API servers in Go. So you get a lot of that. There's some people doing web development in Go. It's not quite there.
So these are people that are moving from Rails or Django or Node.js to Go.
Correct. And you can find story after story of large Silicon Valley companies doing this, even, Fortune 500 companies that are migrating over to Go, some of these RESTful services and things like that.
What's the tooling like for that? Because, you obviously, with Ruby and Python and Node, you have this giant package ecosystem. Is the Go package ecosystem, does it rival that?
So one of the beautiful things about the language, in addition to kind of just writing code in it and being able to kind of jump in, and not really be as confused by people's code is that it compiles down to a static binary, which makes deployment a lot easier. Because if you come from a Ruby or Python background, you're familiar with having to make sure all the modules are over there and make sure the right version of the interpreter is there and all these things. And you just didn't have that problem with Go. You just, here's the binary and, go. And cross compilation from the beginning, not necessarily the beginning, but from early on, was there. There's very little that you have to do to get this thing to run on Mac. So you can develop on Mac, but then compile it for Linux to deploy it. Windows support is built in.
Those compilation issues, that was another one of the focuses of the original mission of the language, the dependency management, the fact that it compiles down to a single binary without dependencies. And so this simplifies the process of taking something from your laptop and making sure it runs also on production servers. Why is that so useful? Why is it so important when deploying to modern infrastructure?
Well, so when we think about deployment, especially when Go was created, we have kind of these dependency management things. And especially if you have multiple applications that are depending on different versions of the same modules, and you kind of get into that dependency nightmare. So just having the static binary to deploy out becomes a much simpler process. Containers, I would say, helped, right? The introduction of containers allowed us to bundle these dependencies inside kind of like an isolated unit that we could move around. But containers hadn't yet been invented. I don't want to say invented, but modernized and popularized, right?
So, speaking of containers, we've done a bunch of shows on the usage and the adoption and migration to Kubernetes. We've done fewer shows about the actual creation and the implementation of Kubernetes. Kubernetes is written in Go, and this might be a perfect example of what kinds of applications Go is useful for, aside from just your run-of-the-mill web application. Kubernetes is essentially a low-level systems application for managing your cloud resources, managing your containers across your different nodes and the pods within those nodes and the containers within those pods. Why was Kubernetes written in Go?
This one is probably a better question for the people who worked on the team, but I vaguely remember hearing that when they were looking at trying to build an open source version of Borg, which is what Kubernetes is based off of, and that's the orchestrator that Google uses internally to schedule out containers, they were looking at more modern languages. And, of course, Go, being created inside Google, I think had some appeal in addition to it, the concurrency primitives and the static compilation. And it just sort of took off. And there was probably the fact that it leveraged Docker under the hood in the beginning. There was probably some degree of using Go because Docker also uses Go, but I wasn't involved in that decision. So, it's a lot of speculation there.
Fair enough. You eventually wrote a book on Go. This is Go in Action. What did you learn about the language while writing Go in Action?
That's a good question. That was a few years ago now since we wrote the book, but I can tell you that I know Go better because of writing the book. It's really interesting when you think that you know a topic really well, but then you want to write about it or speak about it. You do a lot more research to make sure that you're speaking accurately and, dug through a lot of the compiler and standard library just to kind of make sure that we're presenting topics the right way. But even outside of writing the book, there was a lot of, because everybody was new to Go, it took a few years for a lot of idioms and best practices to kind of evolve. And there were common mistakes that a lot of people, including myself, made from the very get-go. Like I overused the crap out of channels when I first started. I was like, oh, I don't need mutexes. That's what channels are for. And there's still a degree of using mutexes, right? If you're just trying to manage state with inside, say, a struct, like a mutex is probably your best bet, right? A channel is more about passing control of data between, two processes.
What are some other lessons of managing concurrency intelligently in Go that you learned while writing the book?
I think there's a lot of when we look at some of these things, like learning best practices, some of the things are, how to intelligently stop Go routines so you don't end up leaking them. They don't spin out there and run forever. When you do things like fan out, fan in, and you want to cancel a request, how do you do those things? And there was a lot of patterns that emerged there. Now we have the context package, which makes it much easier to do that. I wish I sat down and made a list of all these fails, because I know I've made a ton of mistakes, and I know I look at code I wrote back in 2011, 2012, and it appalls me.
Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands, all while increasing the security, reliability, and availability of critical business workloads with Azure. To learn more about Azure Container Service and other Azure services, as well as receive a free ebook by Brendan Burns, go to aka.ms/sedaily. Brendan Burns is the creator of Kubernetes, and his ebook is about some of the distributed systems design lessons that he has learned building Kubernetes. That ebook is available at aka.ms/sedaily. We've had a number of different authors on the show who have written technical books, and they always say that the process of writing a book, you hear the same thing from people who speak at conferences and whatnot, the process of writing a book or a talk hardens your understanding. That's why it is pretty useful for people to teach what they're working on. I want to talk a little bit more about Kubernetes. You were working on Kubernetes when you were at Comcast, and you worked at Comcast for, I think, about a year and a half, and I've seen you speak about building systems there. But the specific application of Kubernetes that you talked about, that you worked on at Comcast, was not something I had heard before. You actually touched on some interesting ways that TV signal actually makes its way to your television set. Can you explain why you were working with Kubernetes at Comcast?
Yeah, so I've actually been working with Docker and Kubernetes since they were released on GitHub. And it's not necessarily because I'm always, pointed in the direction of what the new hot technologies are. It was actually by happenstance because, back then in 2013, 2014, we hadn't even started Gophercon yet. Go hadn't reached the level it has now. So we used to just crawl GitHub looking for interesting projects written in Go. And at the time, I happened to be trying to work on this concept of a framework for building distributed systems. So it sort of fell in line as a better way of doing the problem I was trying to solve. So Brian Kettleson and I actually have contributed to both Docker and Kubernetes, and we wrote the DNS service-based discovery logic for it. So we kind of got involved in the project very, very early on. And I happened to be in between jobs, and Comcast reached out. I got hired there as a systems architect. And basically what they were looking at doing was replacing this physical hardware that multiplexed video channels together into one stream and sent it to the devices that actually modulate the signal onto the cables that make it out to your house. And what they were looking to do is now moving away from that hardware was trying to design kind of a distributed and fault tolerant way of doing this, and as well as making it easy for the video engineers to manage these things. So we started kind of thinking about the design, and Kubernetes kind of got tossed out there in the beginning. I was like, this is a really, really specific problem, and we're probably better off building our own system. And at the time, I had spent the past few years building distributed systems. And my manager at the time was just kind of like, we should really look at Kubernetes. So I started thinking about it like, okay, well, what would this look like, if we had to make it work in Kubernetes? And things sort of fell in place. You start looking at it and you start realizing all the things you would have to build, a scheduler and all these things to build your own distributed system to orchestrate these things out and do failover and recovery. And you start thinking about all the components that exist inside Kubernetes. And that's really when my vision of Kubernetes kind of shifted from, an orchestrator for containers, which is basically, what most people would describe it as. And I started thinking it more in line of like a framework for building distributed systems. It's extremely modular. You can change out the scheduler. You can run them side by side. You can write your own networking plugins. You can write your own types and controllers for those types. And that's really when that kind of hit me, just the extreme power in that. And at the time, they had this thing called third-party resources, which was how you introduced a new type into Kubernetes. And it was really only being used by people developing features for Kubernetes. And it just kind of hit me like, what if we created a type that represented a video stream? And then there's just a YAML file to represent the inputs and outputs and all these things. And we build our own controller. And the controller basically just creates other types within Kubernetes, in this case, a pod for the multiplexer and some of the other things that needed to run beside it. And we could use node affinity and things like that to make sure that it ends up on a host as close to the house as possible. And like just the sheer power of that just astonished me and it really excited me. And so for the past couple of years, I've actually been trying to preach that. I gave a talk in Ghent, Belgium back in February, kind of talking about this. Kubernetes isn't the top layer of the cake, right? We need to start thinking about what those things are and the power of that and kind of teaching people how the control plane works and how you can kind of inject yourself and how and why you might want to customize a particular component. But it's worked really, really well for Comcast. They got a lot of power and functionality with, only having to design the parts that were specific to our domain. We had to do some stuff around network plugins and things like that. We had to add support for real-time threading to Docker. But, at the end of the day, we saved ourselves a ton of development time.
If I recall correctly, the project you were working on was migrating this old way that signal gets delivered to your television via your set-top box to a newer system that delivered the television signal over internet protocol. That's like the degree of low-levelness that this was, right?
Correct. So when we think about the way TV has worked for ages, I'm not sure how long QAM's been around, but at least the 80s, I would say.
So QAM?
QAM is QAM, Quadrature Amplitude Modulation, and it's essentially how the signal goes across the coax cable. And when we think about the way a traditional set-top box works, it works a lot more like the radio in your car. Like coming across that coax cable, depending on the city you live in and how many channels are there, you've got 1.5 gigs to 3 gigs of video just crossing that wire. And when you change the channel on your set-top box, you're essentially just tuning to a frequency on the cable. I think it's 6 megahertz. And then you're demodulating out a channel. So standard definition, you can fit up to 8 in that one frequency. High def, it might be 2. But that's all your set-top box is doing, is it's tuning to that frequency and then demodulating out that particular video stream. And even video on demand, there's a set frequency that allows you to go back up to the cable center and you're like, hey, I want to watch this movie. It looks to see this particular program ID on this frequency is free. So I'm going to start pushing the video down that frequency, and then I'm going to tell your box to tune to that. So then when we start thinking about the Xfinity systems and the fact people use Netflix and Hulu, these are all IP based. So this is on demand. And then you can think about the way that they save bandwidth here is just CDN, right? If 100 people in one neighborhood are watching the same Netflix thing, it's just cached, in a CDN. So that's the way all the new stuff works, and it allows kind of to free up bandwidth and things like that. But you have to support all the old customers. So we have IP video and QAM coming across. Well, you have the multicast video coming across the same backbone. So you're essentially duplicating traffic. So in addition to kind of replacing this hardware, what this multiplexer did was consume the same content that the IP boxes were consuming through the CDN and then pushing it out as the coax video.
And to implement the Kubernetes solution to this, do you have to work much in Go to create those custom third-party resources? Or is that just creating something in a YAML file? What's the developer experience like for creating that custom solution that you had to make?
Yeah, so we used Go. It happened to be a language of choice within the team that I was on. And the client library in Go is, always going to be kind of up to par and have all the newest functionality and be the most tested and supported because Kubernetes itself is written in Go. They have been working on the client library in other languages. And even if you don't use, say, like a client library that's offered by them, you're just talking to the Kubernetes API server through REST calls. So you could use any language. There's just some helpers for, creating these specific types and things like that.
And what were the lessons from that migration, speaking broadly, because it sounded like a pretty long and technical process?
I mean, there were some lessons learned around like running real-time threads inside containers and things of that nature. There were some things we had to create and ultimately we removed because in future versions of Kubernetes, they implemented features that we could use instead of our own custom stuff. We spent a lot of time on networking, obviously, because, this is a very kind of specific problem we had to solve. I guess there were some difficulties too in the way ad insertion worked and kind of opening up ports and things like that. Trying to think, but I mean, it's actually pretty straightforward to create your own controller. And when you break down even the controllers that, are implemented inside Kubernetes, their job is pretty straightforward. Like if we think about the scheduler, the implementation of the scheduler and bin packing and things like this is complex, the algorithm. But when we think about what the component actually does, it's just a long pull to the API server, asking it to give it any pods that don't have a node name assigned. And then it does its thing. It decides which node it should be on based on annotations and using bin packing and things. And then the rest of its job is just to set the node name, push that back to the API server, and that's all the scheduler does. From that point on now, it's on to the Cubelet, which is the thing that runs on every node. And it's doing a similar thing. It's just long polling the API server saying, hey, I want to know about the creation, update or delete of any resource that has my node name. And then it reconciles.
Right. So the Couplet is the node agent. This is an agent that runs on each node and implements pod and container operations. And I want to talk about the Virtual Kubelet project that you worked on. Maybe first, it's good to describe in a little more detail what the Cubelet does.
Yeah, so I'm assuming there's show notes, and I have a blog post where I kind of walk through this if diagrams help. But so the Virtual Kubelet, as you said, is the agent that runs on every one of the worker nodes, the nodes that are actually going to run pods. And it's responsible for a number of things. So it handles communicating with the image registry to pull down the containers and things like that and to clean up after itself. It sets some firewall rules and things like that. It communicates with the container runtime, Docker, things like that to actually create the container. But essentially what its job is just to watch the API server looking for pods that's assigned to it and then reconciling the difference. Like the API server says I'm supposed to have this pod running, but I don't. I need to create it. Or I just got notified that somebody deleted this pod, so now I need to shut down this pod. I mean, it does some other things as far as mounting in config maps and volumes and things of that nature, but it's really the workhorse on the node. It's the thing that does the most work. Everything else is kind of just changing state inside Kubernetes. So if we think about, like, say, a replication controller or a replica set, its job is just to monitor replica set objects and then see how many pods match those labels and then create a new one or delete one based on that. So they're really just kind of creating and modifying objects within the kind of the Kubernetes API server.
So since you joined Microsoft, you started working on the Virtual Kubelet project, and this allows nodes within the Kubernetes cluster to be backed by services outside of that Kubernetes cluster. So rather than using just a node, rather than interfacing with just a node or a virtual machine at the lowest level, you could potentially interface with serverless functions or with ephemeral container instances like the AWS Fargo or Azure Container Instances. Explain the motivation for the virtual kubelet.
Yeah, so there's actually, it's interesting. So we have AKS, which is our managed Kubernetes offering where we manage the control plane for you. And we're not responsible for the team, myself included, that created Virtual Kubelet kind of aren't responsible for the initial idea of doing this. I'm not sure who triggered it, but Brendan Burns wrote the first implementation of it in TypeScript called the ACI connector. And it did the same thing. What kind of myself and the team I worked with are responsible for is kind of this concept of making it its own project where it's modular, where anybody could kind of plug in these interfaces and things like that, and writing it in Go. I think the motivation was when you think about the managed Kubernetes offering, you still have to manage the nodes, and some people don't want to manage the nodes either. So it's kind of this, greenfield, just blue sky idea of, well, what if you didn't have to manage the nodes either? What if you could just have like a nodeless cluster? So for anybody who's not familiar with what ACI is, you can essentially think about it like pods as a service, a group of containers, and you just tell Azure like, hey, I want you to run this thing, and done. And that could work for a lot of people. They don't have complex scenarios where they have these services that need to do service discovery between each other and all these things. They just kind of have like a couple pods that are rather isolated and just ran. But a lot of what it's used for is also, if we think about just kind of like doing batch work, sometimes you just have these processes you just want to run to completion. They're doing database cleanup or all those things. So having kind of this idea of not necessarily running the workload on your main cluster is also appealing, because you could burst out there for when traffic kind of crosses the boundaries of how much resources you have in your cluster. Or maybe you just want to run your batch work out there. You've got CI/CD pipelines where you're trying to run unit tests for every commit. These things can basically just run, and you pay per second as they run. So there was kind of a lot of appeal for some scenarios like that.
So the story is that you've got your Kubernetes cluster that's running your application nodes for your startup, for example. And you have a set of nodes that are up, that are serving the containers to you. So basically, you've just got this set of resources that you have a fixed number of virtual machines. You could spin up more virtual machines to service this cluster over time if you wanted to, but you've, for the most part, you've got a fixed cluster, or otherwise you have to spin up more machines. And throughout the day, you might have bursty workloads. Maybe you have more users that jump on the website that your startup manages, or perhaps you just have MapReduce jobs that are scheduled throughout the day and you have bursty workloads there. Or like you said, you have CI/CD workloads and you want to spin up an instance of your application, or you want to spin up a bunch of instances of your application so that you can parallelize a bunch of tests across those different instances of the application. And for these kinds of usages, you would want to have ad hoc scaling of your cluster. And the cheapest way to do that may not be to purchase more VMs on the fly and then spin up containers on them. The most cost-efficient way might be to use serverless functions or these standalone container instances that you're just spinning up ad hoc. Am I getting it right? Is that's the motivation of this project?
Yeah. I mean, that's exactly right. There's a few different motivations there, and I mean, especially if you think about CI/CD. Right? You've got a couple of options. Like, you could have a VM just sitting there for it, right? Like, most of the time you probably don't want to affect your production cluster for these CI/CD jobs. So you could have VMs just sitting there, and you could have dead days where there's not a lot of commits. And then you can have ones where people are backed up, right? And VM time is VM time, right? If it takes 2 hours to complete these things serially, you're still paying the same amount of money as you are spinning it up and running them in parallel and just having it done. So I think there's a lot of appeal there to just kind of like, hey, just run this until completion in ACI. I pay per second, and I'm never paying for idle time. So, and the creation of Virtual Kubelet is really interesting too, because we talk about Kubernetes objects, right? A node is really just an API object that exists. So you can contact to the API server and just submit something just like you do a pod. And you're like, hey, here's this node. It exists in the cluster. And the API server kind of takes your word for that. And then the virtual kubelet just behaves like the actual kubelet does by monitoring for things that are assigned to it. And then it just translates these objects from, a pod definition, which it sees as part of its watch, into whatever backing service you want that to be. And really, it could be anything, right? So the power of Virtual Kubelet is the first implementation for us was ACI, right? There's a lot of appeal with that. But you could have a provider inside Virtual Kubelet which spins up a virtual machine and then runs just that pod inside your virtual machine for complete isolation. And there's kind of some appeal there as well for people who need that type of isolation for multi-tenancy and things like that.
Failure is unpredictable. You don't know when your system will break, but you know it will happen. Gremlin prepares for these outages. Gremlin provides resilience as a service using chaos engineering techniques pioneered at Netflix and Amazon. Prepare your team for disaster by proactively testing failure scenarios. Max out CPU, black hole, or slow down network traffic to a dependency. Terminate processes and hosts. Each of these shows how your system reacts, allowing you to harden things before a production incident. Check out Gremlin and get a free demo by going to gremlin.com/sedaily. That's gremlin.com/sedaily to get your free demo of how Gremlin can help you prepare with resilience as a service. To describe the abstraction, the architecture of the virtual kubelet in more detail, one constraint of running a typical Kubernetes cluster is that you have to be working with nodes. That is typically you're usually working with a virtual machine. And the virtual kubelet lets you use the abstraction of a provider instead of the abstraction of a node. And so this provider abstraction is what lets you tap into serverless or ACI or whatever other kind of abstraction you want to conjure up that fits the bill of a provider that looks like something that Kubernetes can interface with. Can you describe in more detail what a provider is?
Yeah, so kind of like you said, when we think about how the interactions behave in the Kubernetes world, the virtual kubelet represents itself as a node in the cluster. Therefore, the scheduler can schedule things to it and all of this stuff. And from that point on, the virtual kubelet's responsibility is just to make sure that happens. So inside the core virtual kubelet logic is all kind of like the reconciliation loops and watching Kubernetes and asking the provider like, hey, what pods do you have running? And then determining the differences and saying, oh, well, you need to delete this one. So from the provider interface's responsibility, there's just a simple interface. Tell me all of the pods you have running right now. Create this pod, delete this pod, things of that nature. It doesn't really care how you make that happen. So kind of the sky's the limit for what you can think of for running your container. It just cares that you can tell it what you're running and it can tell you what you need to do to reconcile with what Kubernetes says you're supposed to be doing.
Describe the process of writing the software for Virtual Kubelet.
So the team and I getting together to do that?
Yeah, and the architecture and the scoping and just the process of architecting this.
Yeah, so it was really interesting. We were presented with the ACI connector that was written in TypeScript, and we kind of fell in love with the idea. And we're like, oh, this should definitely be Go, because everybody in kind of the container world is using Go. And if we want more people to contribute, that should be the language. So we knew we needed to rebuild it in Go. And then kind of the idea came up that like, hey, this should really be like a first class project that people can use, especially, when we start thinking about Kubernetes and kind of the cloud space. And, what if you don't even want to manage your own VMs? You just like the power of the orchestration of Kubernetes. So we kind of kicked around ideas and talked a little bit about the design, but it didn't really start coming to fruition until KubeCon. So the primary developers that were going to be the project are kind of like all the Go people who are cloud developer advocates at Microsoft. And then we had some other teams who jumped in as well. It was, I think, 8 teams across Microsoft that came together. So we built it into the Azure tool. People built CI/CD for it and all of these things. It was really amazing to see all the teams come together. But basically what we decided was none of us seemed to be able to fit this into our daily schedules. So let's fly out to KubeCon a week early and we'll just, rent a room in the hotel and just hack on it for a week. So yeah, we threw together the first prototype across 8 teams. I forget how many people were there. I've got a master list on the blog post kind of giving a shout out to everybody, but I think there was like
that sounds pretty fun.
10 people. Yeah. We just got together for a week and just hacked on it. And we had some people from the ACI team there, which was great because, when you couldn't figure out things with the API and they weren't working right, they were there immediately to help.
That sounds like such a great approach. This was in KubeCon Austin, the recent one?
Yes.
Cool. Yeah, and I think, what you mentioned there was Brendan Burns handing this thing to you, and it was originally written in TypeScript, and I just kind of find it funny that, Brendan, he continues to, I guess, lead the evolution of Kubernetes through these prototypes. I mean, he did this also with, the other project he's working on, what is it called? The Metaparticle, right. Like I talked to him a bit about that, and that's another really ambitious project where he threw together a prototype and was like, hey, I think this is cool. And then, that seems to be his way of contributing art is he makes a prototype to illustrate what he's doing and then gets other people to, be excited about it and latch on to those projects.
Yeah, I mean, it's fantastic. And I love that, people are starting to think about these things, and Gabe Monroy, that's where I got kind of like I think he said something about like Kubernetes was never meant to be the top layer of the architectural cake. And the talk I gave in Belgium, I kind of quoted Halt and Catch Fire, saying like, Kubernetes isn't the thing. It's the thing that gets us to the thing. And I think a lot of us who have been around this space for a few years are starting to kind of recognize that, people are really starting to adopt these things, but everybody's still kind of focused on using it as is. And it's really exciting to find people who are, as ambitious as Metaparticle is, maybe that's not how things look, but I love that people are starting to experiment with these things and, what could a good level of abstraction look like on top of Kubernetes? Because it does require a lot of knowledge to kind of learn and use these things. And then especially if you start talking about being an operator too, that's always the big thing I tell people when they're looking to adopt Kubernetes is I work for Microsoft. So would I love you to use AKS? Absolutely. Right. But I think the real power in having a cloud provider do this stuff is just the operational expertise. You don't have to have a Kubernetes expert in every company. There's a lot of ways that distributed systems fail in really interesting ways. And we're stacking up all the operational knowledge into every individual company. And I think there's a lot of power in letting somebody else worry about that while you focus on your own business domain.
So I've done a number of shows about Kubernetes, and one of the things that was interesting that came out of all those shows that I did is the architecture for multi-cloud and how that's going to look. So it seems like in the near future, many companies are going to have Kubernetes clusters on different cloud providers. Like you might have a Kubernetes cluster running on Microsoft, and you might have also a Kubernetes cluster running on Google, and you use different cloud-specific services in conjunction with those Kubernetes clusters. For example, on Microsoft, maybe you're using Cosmos DB, and you want to have a Kubernetes cluster for that database to interact with, so you can stand up an API server just right next to the Cosmos DB setup that you have. And then on Google, maybe you're using Google's, PubSub service together with your Kubernetes instance. How do you anticipate these different Kubernetes clusters on different cloud providers, and how do you see those different Kubernetes clusters communicating with one another?
It's actually really interesting because I do see that happening a lot, both in people experimenting, some people running multi-cloud because they have a Kubernetes cluster running in their own data center. Then, they're leveraging a cloud provider for some other service. But, things like Kubernetes, it's becoming a commodity, right? All the major cloud providers have a Kubernetes offering. We're bound to see more and more companies kind of spin up, kind of in the same vein as, when slices and VMs became popular, right? Like lots and lots of people offered those things. So I think we're going to continue to see more people offer Kubernetes, and it's going to become a commodity. And that's a good thing. But like you said, some of the power that comes in cloud providers is the other services they offer. They've got a lot of machine learning things and cognitive services and databases that you don't have to worry about operating that can run at just massive scales. And their offerings just continue to grow. We're going to get into doing things like quantum computing and things like that. And these are all things you don't want to mess with locally. So I do see that people are probably going to do that. And, a lot of the things that differentiate cloud providers are those additional offerings. So I think as all of those offerings kind of continue to build out, people will end up having clusters in each. I would think you'd probably try to isolate these things in the same way that you do microservices, where they each kind of have their own role and there's kind of light communication between them. It's possible people end up using Federation. Federation is still going kind of ongoing and undergoing some work and looking at the way that
Federation meaning what?
So Kubernetes Federation, now they call it multi-cluster. But essentially the idea is to have a cluster of clusters. So you could talk to the Federation API and say, I need 4 of these things running, 2 in each cluster, and it would go out and create the resources in the individual clusters. You wouldn't have to communicate with them, and it would ensure that happens. It knows how many are running in each cluster, which one it needs to create another one in, and things like that. I mean, there's a group of really, really smart people working on that, and there's definitely been some headway there, and I think they're looking at kind of what the next steps are. But that's also a possibility, but there's also people who kind of think that that's not the way to solve that problem. That's the great thing about new technology, right? Is that we can all experiment with different ways until we figure out what the best ways of doing things are.
That's for sure. Now, to call back to the start of our conversation, your time spent working on Virtual Kubelet, did that articulate even further some of the reasons why Go is useful as a systems programming language?
I think for me, not so much, just because I've been deeply ingrained in the Go world for so long, and I've created so many things surrounding Kubernetes and distributed systems in Go. But one thing that really did come out of that was the importance of open source and just how amazing that can be. And after that, Microsoft actually spun up a group of cloud developer advocates who solely focus on creating open source projects and contributing to them. And that's what myself and Brian Kettleson and Jess Frizzell do now.
Go actually has a large community. What do you see as your role in the community?
I like to think I'm a decent Go developer. And, I try to contribute to as many projects as you can. But a lot of my focus is kind of building community. So, we do our podcast, which is Go Time. Brian Kettleson and I organized Go for Con. We founded the first Go conference we started planning in 2013, but 2014 was the first year. That was kind of by accident. We kept saying for years, like, I wish there was a Go conference. And then somebody on Twitter was like, you should just do that. And we were like, well, how hard could it be, right? And, now, we're over 1,500 people. We'll probably cross 1,800 this year. And that was something I never thought that I would get into.
Do you run it? Is it like a business? Do you run it as a business?
So, we have our day jobs. We don't run it as like a for-profit thing. So it's really been a hobby project for us. One of the great things about working for Microsoft is they allow us to use our company time on these things, like going through all the CFP proposals and things like that. But yeah, it started just because we really wanted the Go conference. We thought it would be awesome. And ignorance is bliss. We're like, how hard could it be? And first year was 750 people. But yeah, and as that happened, I really, really fell in love with the community aspect of things and bringing people together and, mentorship and things like that.
Like, we do meetups for Software Engineering Daily, and the meetups are always pretty fun. And you have great conversations in person. And we spend so much time holed up in our offices or in our apartments that it makes the in-person interaction all that much sweeter. And I was thinking for a little bit about doing a conference, but then I learned a little bit about the economics of it, especially if you want to do it in San Francisco. And it can be murderous. Like there are a lot of stories of people trying to do tech conferences and just losing their shirts on it.
Yeah, there's a lot of things that I wish I never learned, like hotel attrition. And what that essentially is, when you block a bunch of rooms for your attendees, and especially if you're in a major city, you have to do that, or there's the risk that they can't get hotels and then they don't buy tickets. You have to pay for rooms that are not booked. So yeah, Brian and I almost lost our houses the first year because most people didn't book their hotel until like the very last minute. So we were sweating bullets, like, we over $100,000 in hotel rooms and nobody's booking these things. What are we going to do? And now we've grown more comfortable with that because we realize kind of the times of year and how close to the event that we should be looking at. We know that people will buy their tickets early but book their hotels late, but it's still a scary thing and it's a lot of risk because when you get to GopherCon scale now, I think we're sitting on close to $500,000 in hotel rooms right now, and Wi-Fi, like 3 days, I think last year was like $40,000 for Wi-Fi.
I have heard about this. They charge you so much for Wi-Fi.
It's insanity. And so one of the things that I do, I guess I'm not as public about as I should be, is that like Brian and I actually talk with a lot of people, especially people who are organizing the other GopherCons around the world. Like, I'm happy to answer questions for people who are interested in starting conferences and things like that, because I think all technology is needed and somebody has to go out there and kind of take the risk and be the first one. And I can give some advice on things, some stumbling blocks and things you'll learn along the way. And, one of the best things I can say is stay small at first. When you get to convention center size, everything changes. You have to worry about union labor. You have to have insurance policies. You have to have paramedics. You have to worry about fire marshals, all kinds of stuff. But if you stay small enough where you can operate inside of a hotel, if you're spending a lot of money on food and beverage and things like that inside the hotel, a lot of times they're forgiving on the hotel attrition. A lot of times if you have a hotel room block and food and beverage budgets that are large enough, you can get them to give you the space for free. Wi-Fi is cheaper. A lot of times there's a meeting planner that you get connected with inside the hotel that will help you with all these things. So yeah, if you can stay small, 200 to 400 people, and inside of a hotel, you can make it a lot easier on yourself.
All right, well, I'm going to stick to podcasting for a while. So in what ways is Microsoft getting involved in that Go community?
Yeah, so they've hired a lot of people. There's been kind of a lot of press on the scooping up of Go people. Myself, Brian Kettleson, Jess Frizzell, Ashley McNamara, Carolyn Van Slick. And there's some people on the AKS team like Aaron Schlesinger that does like the Go in 5 Minutes podcast. So internally, the AKS teams and things like that all use Go. Go is a first-class citizen in Azure. So we have a very, very good Azure SDK, which has been rewritten to be a lot more idiomatic. In addition to that, a lot of us, they allow us to and kind of push us to go out and speak and teach people in the Go community, to do our podcast, to do our conference, to contribute to open source projects, things like Virtual Kubelet. So they're really, really kind of getting deeply ingrained in the Go community.
You are part of Go Time, as you mentioned, and that's a podcast about Go. It's part of the Changelog network. I'm a big fan of Changelog, big fan of Adam. What's your experience been podcasting? What have you learned in that process?
Yeah, so it's really interesting. And like we could probably have a whole episode on imposter syndrome. So for as much as I've done in the Go community and all of these things, I spent a lot of years kind of hidden. I've never really liked being in the public eye. I feel like anything that I've done, like anybody could have done, really. So the podcast kind of came around. We started talking about doing one, and I was like, I really should start blogging or speaking. And as we were talking kind of before the show, I DJ'd when I was younger. So the idea of putting myself out there, it sounded a lot easier to stick a microphone in front of my face. because I was used to doing that, and you kind of do the persona. So we started doing it, and I don't think we really anticipated for it to be as successful as it has been. And it's really awesome getting, some of the guests we get on the show and the topics that end up coming up, and sometimes even the accidental topics that come up are just really amazing. You find it hard to stay on topic. You're like, wow, this is really, really great. Just re-themed episode.
I hear you. I mean, that's why I started this. And I, just like you encourage people with the conference, I encourage people to start podcasting, partly out of self-interest because I want more podcasts to listen to, but partly because it's just an excuse to call up very interesting people. And actually, a close friend of mine recently was telling me, like, talking to you is sometimes really annoying because you just ask questions like you're on a podcast all the time. And it made me have to check myself and be like, oh, actually, okay, I guess I should recalibrate myself to the pedestrian conversation sometimes, because you can't just have every conversation be like a podcast. Not every conversation is super technical and podcasty.
Yeah, and ours, we've tried to keep, one of the things we wanted to do from the beginning was not be sort of like a 2020 question answer. So we really, really tried to set it up where it's really like we're having, like, they're really a co-host of the show, where it's just us sitting around at a table or something, just talking about Go, and the listeners kind of get to be a bird on the wall, a fly on the wall. So that makes it a little easier to not kind of feel like you're interrogating somebody. But sometimes they do come out that way. One of the most interesting things that have come out of podcasting for me is that you don't really realize that you have a recognizable voice until you meet people at conferences that recognize my voice. And they're
right. They're like,
"Go
I
time?"
thought you were just a disembodied voice.
It's really interesting and cool. You're just like, they're like, "Go time?" And you're like, yeah. They're like, I heard your voice. And for me, I have a twin brother, so I'm used to hearing the sound of my own voice.
All right. Well, Erik, it's been great talking to you. Really good conversation. And I look forward to seeing, what else Microsoft is doing in the Go world and seeing what you do in it as well.
Yeah. Thanks so much for having me on. This is fun.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily. And thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow.